Hello, my name is Remington Henderson, and today I'll be talking about silicates, the most abundant matter in Earth's crust. Together, silicon and oxygen form covalent atomic solids called silicates with a small amount of other elements included in some cases. Silicates are often found in rocks, soils, and clays. In particular, I will be speaking about 5 structures of silicates today: quartz and glass, aluminosilicates, individual silicate units, silicate chains, and silicate sheets. First off, we see that silicon binds with 4 oxygens to form silica. These oxygen atoms have an sp3 hybridization with silicon, create a tetrahedral shape, and each have an unpaired electron. These unpaired electrons can be filled by covalently bonding to another silicon atom. This overall is quartz, and its formula unit is SiO2. Glass can be created by heating SiO2 over 1500 degrees Celsius and then is cooled quickly. The glass is an amorphous form of SiO2. Next we have aluminosilicates. These are similar to quartz, but where aluminum atoms fill in for where the silicon atoms would be. This has an overall formula unit of AlO2-, where the negative charge can then be balanced by a counterion such as sodium in the substance albite or by calcium in the substance anthrite. As stated before, the structure of silica has 4 oxygen atoms with unpaired electrons that often bind with other elements to fill their octet. Another way these octets can be filled is by picking up electrons from metals to form SiO4 4- ions. When these silicate ions are neutralized by cations, the resulting substances are called orthosilicates. In some cases, 2 silica units will share 1 oxygen atom, having 7 oxygen atoms total instead of 8, and will gain 6 electrons to fill their oxygen's octets. Substances formed by these silicate ions with cations are called pyrosilicates. The silicate ions can form long chains where connecting units share 1 oxygen atom. These structures are called pyroxenes and have a formula unit of SiO3 2-. Chains can be held together by ionic bonds to metal cations in between the chains, and one such example is diopside, where both calcium and magnesium atoms occupy lattice points between the chains. Continuing on from the previous slide, some silicates have 2 chains bonded together called amphiboles. These double-chain structures often result in fibrous minerals such as asbestos. Silicate sheets are similar to silicate chains, but where 3 of the tetrahedron's oxygens are being shared. These structures are called phyllosilicates and have a formula unit of Si2O5 2-. These sheets can then be ionically bonded to metal cations lying in between the sheets. Examples include talc and mica. Finally, below is a compiled list of the silicate structures discussed and their formula units. Thank you for watching my video on silicate structures.